Hi everyone, this is Miss Janasek. I'm going to be going through how to multiply and divide rational expressions today. Keep in mind your last quiz/test grade will be on adding and subtracting, which you've already learned, and multiplying and dividing rational expressions. These are the last things that we're going to learn. The last lesson, yay! Your quiz will be on Thursday. Okay, your quiz will be Thursday, May the 11th. So make sure that you are prepared for that. Okay. All right, let's talk about multiplying and dividing. When we multiply fractions, we multiply the numerators, the tops, and we multiply the denominators, the bottoms. But division is a little trickier. So let's look at a regular problem where we're dividing, like just fractions without any variables in them. So the first fraction will stay the same. The division symbol will change to a multiplication symbol, and the second fraction will flip. So it'd be 10 over 3 instead of 3 over 10. Then we will multiply the numerators, multiply the denominators, and then simplify if necessary. Both of these numbers are divisible by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. So 4/3 is the final answer. So we're going to do something similar. We're not actually talking about the rational function yet. So I'm going to skip over this section number 2. Okay, we're not actually talking about the function. We're only talking about expressions in this particular section. Okay, we are focusing on expressions, not equations or functions just yet. Now, remember, multiplying is not too bad, guys. Multiplying, we multiply the tops, we multiply the bottoms, and it is commutative. Which really just means x times y is the same thing as y times x. So it doesn't matter which variable you put first. Usually I go alphabetically. So x times y is xy, a times b is ab. Division, when we have a rational expression like the one you see here, we always need to factor first. Factor the numerator and factor the denominator. So in the numerator, the first thing we want to do is factor out our GCF, which in this case is 2. Divide each of those terms by 2. So we get minus 2x, and negative 30 divided by 2 is negative 15. Okay. And we're going to factor it some more in just a moment. Now let's factor the denominator. So x squared is x times x, and we're trying to come up with two numbers that multiply to give us the negative 10. So that could either be negative 5 times 2 or negative 2 times 5. But remember, they also have to add up to that middle number, the negative 3. So these are the two that add up to negative 3. So I'm going to plug those in at the bottom, x minus 5 and x plus 2. And now we need to do the same thing on top. We need to factor the expression that's in the parentheses. So we're coming up with x times x to give us the x squared, but we need to come up with two numbers that multiply to give us 15. So it's either going to be, and it's negative 15. So negative 5 times 3 or negative 3 times 5. And the one that adds up to a negative 2, the middle term, is negative 5 and 3. Okay, and the bottom stays the same, x minus 5 times x plus 2. Now, if you see any of those binomials the same on top and bottom, we can cancel them out because anything divided by itself is 1. And I can show you an example over here on the side. 2 divided by 2 is 1. 10 divided by 10 is 1. A million divided by a million is 1. Well, x minus 5 and x minus 5, if we were to divide anything by itself, it should still equal 1. So the fact that we see an x minus 5 on top and an x minus 5 on bottom, if we were to divide them, we would get 1. Therefore, they are going to cancel out. So our remaining answer would be 2 times x plus 3 on top, and the bottom is just x plus 2. That is the most simplified form of this particular expression. So let's go ahead and look at another example. We're multiplying the tops and bottoms, but as we said, simplify or factor first. Factoring first is the most important thing. So let's go ahead and factor this. Take a moment to factor, pause the screen, factor them, and then check your answers. So I have factored the numerator to x plus 3 times x plus 2 in the first fraction, and the denominator is x minus 5 times x plus 4. And then I did the same, I factored the numerator and denominator of the second fraction, and remember they are being multiplied together. So all four of these binomials that are in the numerator will all be together, and all four of them will be in the bottom also together. Now remember, if we see anything on top and bottom, like we see an x plus 4 and an x plus 4, that means that we can cancel those out. So what else do we have? We also have an x plus 2 and an x plus 2, so I'm going to cancel those out as well. And indeed, we also have an x minus 1 and an x minus 1, and those will also cancel out. So we're actually not left with very much. Our final answer has an x plus 3 in top and an x minus 5 in bottom. And wow, that gets really, really, really simplified. So by factoring first, you're saving yourself a lot of heartache trying to multiply a trinomial times a trinomial, and then factoring afterwards. Factoring first helps you to eliminate a lot of things. So let's look at some special cases. This first one is really not as bad as you might think. Remember we talked about how multiplication is commutative and you can change the order? Same thing goes with multiplication. I can rewrite the denominator as x plus 3. The reason why I can do that is because addition is commutative. I know that 1 plus 2 is 3, but 2 plus 1 is also 3. It doesn't matter the order that they were added in. And since I changed it, now the numerator and denominator look exactly the same, and we know anything divided by itself is 1. Not too bad, right? So in this one, example 2, right below it, they're also very similar, and I can still have them switch places, the numerator staying the same and the denominator changing. But my biggest problem here is that when I switch them, the x must still stay negative and the 3 must still stay positive when they switch. So what I'm going to do is factor out a negative 1, like the GCF in the bottom. I'm going to factor out a negative 1. And when I do that, now I have x minus 3 over x minus 3. So what's going to happen here is we said that if we had something divided by itself, it was equal to 1. So now we have 1 in the numerator and negative 1 in the denominator, and when they divide, we get negative 1. Last one, example number 3. This one is already in its most simplest form. That can happen sometimes. So let's go ahead and go to the next page. All right, here's a division one. Now, just like we talked about division earlier, you have to take the first fraction stays the same, and then we change the division to multiplication, and we flip the second fraction. So this one's x minus 4 over x plus 2. Now, we had learned that we could swap some of this out, and so we very well may need to do that. This one right here, we're going to change the order of that, and let's see what it looks like. So what I'm doing here is multiplying the numerator and the denominator by negative 1. So now that makes the top negative 1x and positive 3, and the bottom negative 4 and positive x. And that is great because in the other fraction, we have x minus 4 in the numerator, and that is equivalent to negative 4 plus x. Because if those two switched places, these two here, oh my goodness, sorry guys. If these two switched spots, it would look exactly like x minus 4. They are equivalent, which means that they can be canceled out as well because x minus 4 divided by x minus 4 is 1, leaving us with negative x plus 3 over x plus 2. Okay, so that's the basics of multiplying and dividing. What I'd like you to do is try the first two here, this division and this multiplication, and let's see how we do on it. Okay, remember factor first, and then multiply or divide and cancel out what you can cancel out. Try them on your own, pause the video, and then check your work when you unpause. All right, guys, so here are the answers for the first two. Notice I factored the numerator and denominator of the first fraction, and then same thing for the second fraction. Only in the second fraction, I only needed to factor out the GCF, which was x for both of them. And then from there, I needed to remember, since it's division, the first fraction stays the same, the division changed to multiplication, and then the second fraction needed to flip, which did allow me to cancel out the x's on top and bottom. You've got an x plus 2 on top and bottom, and an x minus 2 on top and bottom. And remember, anything divided by itself is 1, and that's why we can cancel those out. The only thing remaining was the x plus 5 on top and the x minus 3 on bottom. And then example 2, same thing, we had to factor the numerator and denominator, but we didn't need to flip anything this time. Because remember, it is multiplication. You don't need to change anything or flip any fractions. Okay, the x minus 5 is canceled, the x minus 2 is canceled, leaving with me with x plus 2 on top and 2x plus 1 on the bottom. So really, it's really heavy on factoring. To do this, you need to be able to factor. If you're struggling with factoring, make sure to go into tutoring with Miss Silva, Miss Gonzalez, myself, I'm in 8310, or Miss Villers. Now take a moment to try questions 3 and 4. Pause the video, try them, and then unpause the video to check your answers. Looking at that first one, guys, you can see that I have factored it out. You'll also notice that when we switch from division to multiplication, you had to flip the second fraction, remember? I did do that. And then also you'll notice one other thing, I did change negative 2 plus x to x minus 2. They mean the same thing. All I did was have them switch places. And then the negative 2 stayed negative, the x stayed positive. I canceled out what I could cancel out, and then you could see what was left. Remember, you can only cancel out if you see something in the numerator that you also see in the denominator, because anything divided by itself is 1. Now, the question on the right was a little different because they weren't binomials. So we did have to use our exponent rules. When you're multiplying, you add the exponents. So we added these two to get 4. Remember, we did have to change from division to multiplication, and we flipped the second fraction. Okay, so now from here, we need to simplify it a little bit. We need to simplify the fraction. They're both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. This is the only x, so it remained as it was, x to the 4th, but then we need to divide the y's. Remember, if there's no fraction or no exponent, then the exponent is a 1. So while we're doing this, division of exponents means we need to subtract those exponents. So in this case, it is y to the 3 minus 1, and 3 minus 1 is 2. So it's y to the second power. So we had to use our laws of exponents for that one. Okay, you do have a practice and a review for the quiz, and both of those are going to be due the day of the quiz, which is Thursday. So you have today, tomorrow, and Wednesday in class to practice. I will try to leave an answer key so that you have something to look at. Have a good day, guys. Bye.